Hello everyone and welcome to another Würth Elektronik ISOS webinar. My name is Markus Eberle and I will moderate this webinar today. We are very pleased that you took the time to participate in our webinar. The topic of today's webinar is not all Bluetooth is the same, standards, applications and solutions explained. Our speaker today is Jairo Bustos, who is working at Würth Elektronik ISOS. He will hold today's webinar and also answer your questions. Before we start the webinar, I would like to point out one thing. You will be muted during the webinar today. This means that you cannot ask us questions via microphone today. Nevertheless, you have the opportunity to ask us questions during the webinar at any time via the chat function. You are in the webinar control panel. Today's webinar will be about 30 minutes long. The chat questions will then be answered in a question-answer session following the webinar. We have scheduled for this around 10 to 15 minutes. And if we don't have the time in the live session to answer all your questions, we will answer them later on via email. You will also receive the link to the presentation from today, as well as to the recording of this webinar only in the next few days. Now I will hand over to our speaker and I wish you an exciting webinar.
So, ladies and gentlemen, hello everybody. Thank you, Marcus, for the introduction to the webinar. I'm also pleased to be here and talk about Bluetooth today. My name is Jairo Bustos, as my colleague Marcus said, and I am product manager for RF modules at Würth Electronics. First of all, I would like to show you where does the Bluetooth come from. It's an interesting story behind. So Bluetooth comes from the Danish King Harald Bluetooth, and especially also the logo from Bluetooth is formed by the Nordic alphabet H and the B. That when we put them together, we have the Bluetooth symbol that everybody knows. This was standardized by the Bluetooth Special Interest Group in 1999, and we will see later on what are the different versions that we have. As I was saying, we started in 1999 with the first version of the Bluetooth, so Bluetooth 1.x. This is known as Bluetooth Classic, and the first definition was made by the IEEE standard organization in the standard 802.15.1. A few years later, the second version of the Bluetooth was released with some new services, some new functions, as for example, the enhanced data rate, as we can see here. This is a special feature in order to achieve a higher data transfer. The Bluetooth 3.x version, which is only still classic Bluetooth and achieves higher speeds. And then we have the Bluetooth 4.x and 5.x, which is known as Bluetooth Low Energy or Bluetooth LE, which was specifically focused for IoT applications. With the fifth version of the Bluetooth Low Energy or version 5.0 from the Bluetooth Low Energy, we have a lower energy modus and long advertising packets. One of the main features is basically that in Bluetooth 5.0, the module will go quicker into sleep modus. So it will have a longer sleep modus phase, which then at the same time saves a lot of energy. It is important to mention here that Bluetooth Classic and Bluetooth Low Energy are not compatible with one another. They are two different standards. And it is generally the question if I can, combine or if I can connect a basic, a classic module, Bluetooth module to a low energy module. The answer is no, it is not possible. Unless the module has both versions installed. So if the module has the Bluetooth Classic and the Bluetooth Low Energy, then you can connect either to Classic or to Low Energy. It is also good to mention here that Bluetooth Low Energy Audio and Bluetooth Low Energy Mesh are different standards. They are not as per se the Bluetooth Low Energy. So those are different standards, and also the modules need to be compatible with those. Here we can see a picture of the different frequencies that are used in Bluetooth. So Bluetooth is basically working at the frequency of 2.4 gigahertz with signals of up to 2 megabyte per second. The signals are modulated against following the Gaussian frequency shift keying system. And as we can see in the picture, there are 40 different channels which share the Bluetooth low energy, also the Wi-Fi, and also proprietary protocols. Now you can imagine that the different channels from the different protocols, so the different technologies will definitely collide with one another. In this case, we can see that we have 3 advertising channels which are not in the Wi-Fi channels 1, 6, and 11. So those are the most frequently used Wi-Fi channels 1, 6, and 11. And those advertising channels for Bluetooth are outside of the scope of those frequency ranges. So this means they will not collide. Then we have 37 extra channels for data transmission. Basically, some of those channels, and you can see that on the picture, are light blue. Those will collide or will share the same frequencies as the Wi-Fi channels. And the dark blue ones, they do not share the same frequencies as those Wi-Fi channels. So they are, let's say, safer. Nevertheless, as I was saying, it is definitely there is definitely a possibility that the different packets will collide with one another, but the Bluetooth technology is robust against such disturbances, and specifically due to this frequency shifting system, it is more or less, let's say, guaranteed that not so many packets will collide, so that the connection or the data transfer is not possible at all. There are different roles that the Bluetooth modules or the Bluetooth nodes can take. There are basically 2 different methods. One is the connection-based, and one is the connection-less system. In connection-based, we can have 2 types of roles. We have the peripheral role or the central role. And in connection-less, we have the broadcaster and the observer role. The peripheral will provide services and advertise that he is here. We will see that later on. So it's basically the module or the product that says, I am here and I want to connect. The central will scan those advertising packets and will initiate the connection. The broadcaster will only transmit advertising events, so it will not receive any packets. And the observer will only receive the packets and will not transmit. An example of the peripheral and central connection would be a sensor or a hands-free microphone system in the car, and the central device would be the smartphone. And the broadcaster observer example would be a sensor beacon or a beacon receiver. So here it is an example when we are at a congress and one stand is willing to send information to the people walking around the stand. They will send beacons, and if anybody has the module, the Bluetooth on, this receiver will receive the beacon, and there will be some kind of message as, for example, come and visit us. Today we have a very cool program, or have a look at our booth, or whatever information the broadcaster is sending. As I said before, we have an advertising phase in which a peripheral device will advertise or will inform the environment that he is there and he is willing to create a connection. He's willing to connect to somebody. These, as we said before, these advertising packets will take place over the channels 37, 38, and 39. And the central device will be constantly scanning these channels to see, is there any advertising packet here? Is there any peripheral device that wants to connect with me? And so on, this the whole time. After that, we have a connection setup, which we can also see here on the right side of the screen. We have a peripheral device and a central device, which I said, how I said they would advertise that there is a device wanting to connect. The central device will say, I can connect with you. And then they will start a negotiation time and, if needed, an authentication or encryption phase. So for example, in the negotiating of the timing, they will establish how many, after how many milliseconds the packet will be sent. Also, they will establish within others that the maximum transmission unit of the packet. So how big will the packet be? They will also say what kind of PHY do I have? Do I have a 1 megabit PHY? Do I have a 2 megabit PHY? And in terms of authentication and encryption, they will basically say, do we need to encrypt the communication for any security purposes, or do we also need to authenticate with each other? So this is a very clear example. When we jump into the car, sometimes we do get the information from the audio system of the car that there is a password and that you need to check with your mobile phone the password. And if the numbers are the same, then you click on OK, and then the connection will be set up. So this is one clear example of the authentication process during the connection setup phase of the Bluetooth connection. And finally, in this kind of phase, there will be a profile readout. So every single device, the peripheral and the central, they can offer different services. And these services will be exchanged. So the peripheral device will say, I have, for example, the Bluetooth low energy audio service, or I have the battery service with which I can say how much battery I have, and so on and so forth. And this is exactly the exchange of information that will take place during this phase of the connection setup. And after that, we are ready to go. We can start transmitting data. Now, as I said before, the time slots in which the data will be sent will be defined during the connection setup phase. And here we can see there is data, and then we go into sleep modus. Again, data, again, sleep modus. So this is a special feature of the Bluetooth low energy protocol in terms of energy saving. The throughput can be between 23 and 247 bytes per connection interval. So if, for example, we have 100 milliseconds connection interval, then and the 247 maximum transmission unit, then we have a 2.47 kilobyte per second communication between the peripheral and the central device. A specific example of this kind of data transmission that we have with our modules is we will send 4 different packets of data, so 241 bytes, and then we will go to sleep. Now, if you have a further interest, you can read about our Proteus-I series on our website. I would like to talk about now about the different firmware options that we have. Basically, the modules that we offer, they can be standard, or not only Würth Electronics, but generally speaking, the modules that are on the market, they can be standard modules with standard firmware. There can also be modules with no firmware, and then you can either build your own firmware or you can get somebody developing the software for you. So if you want to have if you have a host controller with which you want to communicate over the UART with the module, and you only need to take the standard functions or the standard services that are given, then definitely you would like to have a standard firmware or the standard product. Some of the benefits are that, of course, it is a standard firmware, so that is also subject to changes or to new developments, new versions of the software. The module will also be certified, so you don't need to go back and certify the module yourself. The module will also have a standard part number, which, for example, for Würth Electronics means that the goods will be on stock. You will also have a fully verified, electrical tested and validated module. And there are also possibilities of updating the software or the firmware of the module over the air or with the UART. Now, if you, for example, don't have space for a host controller, or you don't have the sufficient energy to have a host controller, and you want to reduce the size or reduce the energy consumption, then you can definitely take a different module, which would be your own firmware development. In this case, the module does not come with a standard firmware. The module will probably have a standard part number. It will be also electrically tested. One of the, let's say, drawbacks is that the module will not be certified, so you need to go back and certify the modules yourself. unless, as I show in the next slide, unless you ask for a customized firmware, where the development costs naturally, obviously will need to be taken care of from the customer side, but the certifications will not be needed because this is something that we will take care of. If you wish to build your own firmware, generally speaking, the chip manufacturers will also provide a software development kit, which is downloadable from the website of the manufacturer. In our case, I will show it also later on. We have Nordic chips in our modules. And Nordic does actually provide on their website a software development kit, which obviously allows everybody to create their own firmware or to adapt the firmware on our modules to their needs. Now, I would like to give you our view of why a build your own firmware is a second best choice. Now, of course, as I said before, it is possible if you have the manpower, if you have the resources in your company, if you have a software development team that can take care of that, definitely go ahead. It is a possibility. However, this is not always the case. And for example, here we can see that there are some fixed costs which reduce to the module when you buy, let's say, Würth Elektronik's module off the shelf. It can be a little bit more expensive as when you develop your own hardware. Nevertheless, the costs, the fixed costs, stop there if you buy an off-the-shelf module. Whereas if you build your own device or you build your own firmware, you have to buy the different components, you have the hardware development costs, you have the firmware development costs, and of course, you also need to have the measurement equipment, so you also need to buy those if you don't have them. In terms of variable costs, you have certifications, declarations, conformities, which we will take care of. If you need to do that, it will be more expensive for you. I suppose customers will only release or provide one module for certification. Since we provide more modules for certification, then we get obviously better offers for those. And in terms of opportunity costs, it is of course to say that the delay of the market entry when you or the customer does their own device or their own firmware is obviously longer than if they buy the off-the-shelf module. If I were to show some kind of applications, I mean, I have already spoken about some applications during the past slides, but there are other different applications that are also interesting and are also quite visual and will allow you to get a good picture of what or where can I use Bluetooth. For example, if you wake up in the morning and you connect your mobile phone to the coffee machine and you want to check, oh, is there from bed, is there any water? Are there any beans in the coffee machine? Is the temperature okay? Or maybe I can start the machine that when I go down to the kitchen or when I go out to the kitchen, I have my coffee already prepared. This is something that you can do with using Bluetooth. As I said before, in case of marketing URLs that need to be sent as a beacon to any visitors around the sales booth, if you want to have any module to module or module to mobile phone data streaming, for example, the performance data of a bike gear, or if you want to record machine data from your production line, from your industry environment, you want to check on the different robots that are working on the production line. Also for agricultural environments, this is also becoming very known and very important for the agriculture. And finally, if you want to, for example, control the on or off switching of a machine with some PMW signals. Now, please allow me to take a few minutes of your time and offer you or show you also which kind of modules we have to offer, since we have a lot of different modules that we can provide, and also with different features and different services. We have the different Proteus modules. They are called Proteus, Proteus-I, Proteus-II, 3, and Proteus-E. Basically, and I will not go into much detail about the whole table here, but what you can see here is that basically the differences are on one side the different standards that are used. So, for example, for the Proteus-I series, we have the 4.2 Bluetooth Low Energy standard, and for all the other Proteus modules, we have the fifth version of the Bluetooth Low Energy. Also very important, the output power for Proteus-E, Proteus-I, and Proteus-II, we have 4 dBms, whereas for Proteus-III, we have the 8 dBms. This is definitely having an impact on the range of the communication. Also, you can see the power consumption from 5.4 milliamps to 7.7 milliamps. You can also see the payload. It is different from Proteus-E to Proteus-III. So either we have 243 bytes or 964 bytes. And a good thing also about the Proteus-E and the Proteus-III series are that we have additional GPIO pins. For example, in the Proteus, we have 2 GPIO pins, and for the Proteus-III, we have 6. So this allows you to connect to the module. More details about the different modules you can find on our website, we-online.com. If you go to the wireless and connectivity radio modules section, you will find the Bluetooth, and you will find datasheets and user manuals, and you can read a little bit more about these modules. As I said before, since there is also the possibility that customers want to build their own firmware, we also provide a module which is called Ophelia-1, which has no firmware at all. Now, of course, it is also possible to have a Proteus-III and just, delete the software that's on it and then build your own firmware. But the Ophelia-1 is a specific hardware module with no firmware that we provide our customers when it comes to an own development of the firmware. And a very interesting module is the CTBus-1. So this combines proprietary and Bluetooth. So we have a proprietary protocol also over the 2.4 gigahertz. And it combines also the Bluetooth Low Energy. So basically, it combines our Thyone-I module with our Proteus-III module. So you have 2 modules in one, and you can change from one to the other. Now that is my presentation. I come to an end of the presentation. So I thank you all already in advance for your time, for listening to us. And I give the word over to my colleague, Markus. If there are any questions, I'm happy to answer them.
At first, thank you very much, Jairo, for your presentation. Yeah, I really enjoyed it to listen to you. So I hope on your side it was the same thing. So yeah, as you've mentioned, now we would like to turn our attention to your questions. And in the meantime of the webinar, we already got some questions. So yeah, let's just start in. Before we start in, you have the opportunity to ask us the questions with the chat function. You will find that in the webinar control panel. And if we don't have the time now in the live session to answer all your questions, we will answer them later on via email. So, Jairo, then let's start with the questions. Yeah, first question I see here. I have a Bluetooth Classic module in operation. Can I extend the functionality with the new Bluetooth LE?
Yeah, Markus, thank you very much for the question. Unfortunately, it's not possible to connect the Bluetooth Classic with the Bluetooth Low Energy. As I said before, those are 2 different standards, and the modules will not be able to communicate with one another. So it's not possible unless we have a module that contains both classic and low energy. Then it is possible because it will be able to differentiate. Do I want to connect to a classic, or do I want to connect to a low energy? Then it will be possible. But if we have a module with only classic or only low energy, we cannot connect it with the other standard.
Okay, thank you very much. Then let's just go on with the next question. So how can I connect the Proteus modules? Do you have apps for Android, iOS, or Windows, or is that already integrated in each operating system?
Yes, we do have the Proteus Connect app, which is downloadable from our website. If you go to we-online.com and then you go to the wireless connectivity and sensors area down to radio modules and Bluetooth, you will be able to find a link to download the app. It is available for Google or for Android systems. It's available also for iOS systems, and also the source code is available at GitHub. So you can also download it and you can create your own. You can work around with the code or with the app to adapt it to your necessities.
Okay, thank you very much for your explanation. So yeah, then just by the way, if you after the webinar, if you have a question left, you can just also email us. You see the email addresses at the moment on the screen. So then next question, Jairo. For my application, I would need a customized firmware. Does WE offer software customization or should I implement it myself?
Yeah, so we do definitely offer you the possibility of developing your own firmware, or we developing the firmware for you. As I said in the presentation, the benefit of that will be that yeah, of course you have the costs of the software development, but you will not have the cost of the certification. So we will certify the module, and the certification will still be there. If you go for the firmware yourself, then you will need definitely to apply for the certification. But yes, it is possible. If you need that, just contact our sales team, and they will be more than happy to support, to give you an offer, and we can support with that.
Okay, thank you very much. Then yeah, let's just go on with the next question. The combo module CETIBOS seems interesting. Okay, that's good to hear. Can you please explain in a few words what the module can do?
Yes, it is definitely interesting. The module builds, as I said in the presentation, two different products from us. So the one on one side, the Thyone-I, which is a proprietary protocol, and also the Bluetooth low energy or the Proteus-I module, which builds in a Bluetooth low energy protocol. The main difference is that the proprietary protocol is available or provides a communication between point to point, but it will also support mesh networks, whereas the Proteus-I module or the Bluetooth does not provide the mesh network support. The option of choosing the Thyone or the Proteus-I, or in other words, the proprietary protocol or the Bluetooth protocol, this can happen during the communication all the time. So you can switch the module from one modus to the other modus. Of course, you need to reset the module, but when you start it, you can say, oh, I want the module to work as a Thyone or as a proprietary, or I want the module to work as a Bluetooth module. So yes, these are the main differences.
Okay, thank you very much. Then just regarding the time, I think we have time left for one last question. But before that, just the information for you at the end of the webinar, you will be asked to participate in a feedback survey. Of course, we would be pleased if you take the time to fill out the survey and help us to improve our webinars. So then let's just jump into the last question. Hayo, I need a transparent Bluetooth interface. Is this available in the Proteus modules?
Yes, it's possible. It's available, but only in the peripheral mode. So if the module is configured as a peripheral node, then it's possible to have a transparent Bluetooth interface. This information you can also find in our user manuals. Again, if you go to the website and you search for either Proteus or you go over the whole structure of the website until you get to the Bluetooth modules, you will be able to download the user manual. And here you can find also all the information about, for example, or within others, the transparent Bluetooth interface.
Okay, so now we are finished with our webinar. I see there are some questions left, but yeah, as said before, we will answer them via email afterwards. So thank you very much for your attention, and I hope you enjoyed our webinar. Also, many thanks to you, Jairo, for your time today.
Thank you very much, Markus. It was a pleasure to be here with all of you. And as Markus said, feel free to contact us and ask further questions.
Yeah, so I hope you will hear us at the next webinar, and I wish you a good day. Thank you and goodbye.